This is a solution to another example problem. This is out of the Uniform Circular Motion chapter of the Physics Resource Book. Number 20. When traveling down a road at a constant speed of 55 miles per hour, that's 26.4 meters per second, the tangential velocity of the wheels is also 55 miles per hour. If a car tire is 65 centimeters in diameter, then what is the period and frequency of the spinning car tire, and what is the centripetal acceleration of a rock stuck in the tire's tread? So we're going to assume that this is going to be the diameter of the tire where it's stuck. All right, cool fact in the problem. The car's speed equals the tangential velocity of the wheels. So if you're driving down the road, whatever it says on the speedometer, that's how fast the edge of the car tire is spinning. That's cool information. Okay, so let's look at the givens. I know my givens. I know my tangential velocity is the speed of the car. That's how fast the wheels are going too, so that's cool. 24.6 meters per second. The diameter is 0.650 meters, which means the radius is half that, 0.325. All right, so our strategy is going to be kind of simple. We're going to find a formula with my givens. That's going to be my velocity and my radius, and then my unknown, which is going to be the period of the spinning wheel. That's t, capital T. So I'll start with my equations, and then I'll go through a process of elimination, see which one of these has these three variables. So the first one, that's got t in my list, r is in my list, and vt's in my list. No way. That's the one to use. So that's the equation I'm going to use to solve this problem. So Vt equals 2 pi r over t. So I'm going to isolate my unknown. That means I'm going to rearrange my equation to isolate it for t. So I multiplied both sides by t, and then I divided both sides by the tangential velocity. And that gave me t equals 2 pi r divided by the tangential velocity. Then I'll put in my numbers with their units. It's important to put it in with the units. And I get my time to be 0.0773. And the second part of the question was, what was the frequency? And I know that frequency is just the inverse of the period of motion. So the frequency is just 1 over that, or 12.9 hertz. So that's the frequency for the tire spinning. Part B. So let's see. In part B, I'm going to use a very similar strategy. I'm going to find the equation with the tangential velocity r and a in it. So here are my equations, and I'll start going down my list. So let's see, r, that's in my list down below, and t is not in my list. I'm looking for v, r, and a. So t is not in my list of v, r, and a. I'm going to get rid of it. Now this list, just as a reminder, this comes from my givens, which is my tangential velocity and the radius, and the question, which is the centripetal acceleration. That's where the a comes from. Okay, let's move to the next equation. If I look at it, AC is in my list, velocity is in my list, but t is not in my list, so forget that equation. Next one, AC is in my list, t is in my list, not in my list. That's not it either. AC is equal to, let's see, VT is in my list, A is in my list, and R is in my list. Hey, that's it. So that's the equation I'm going to use. AC is equal to V squared over R. So AC is equal to V squared over R. I'll have to isolate my unknown, which is just AC. So that's the equation gives me that. That's great. Don't need to move anything around. So AC is equal to my value, 26.4 meters per second squared, divided by the radius, not the diameter, but the radius in meters, so 0.325. So my acceleration is 2140 meters per second squared. Wow, that is a huge amount of g's. Just as an approximation, if I divided that by 10, that's 214 g's. That's a tremendous, tremendous centripetal acceleration.